Alright, so let's look at some examples. For our example, we will consider the fractional knapsack problem. So what is the fractional knapsack problem? It gives us a scenario where we need to fill a knapsack of a specific capacity as efficiently as possible with three given items of three different weights and values. Our goal is to make sure that the most valuable item can be taken while carrying as much weight as possible. So, let's consider a specific example. Suppose we have a knapsack with a capacity of 50, item 1 with weight 10 and a value of 60, item 2 with a weight 20 and a value of 100, and a third item of weight 30 and a value of 60. Our goal is to completely fill the knapsack so that the capacity will be 0, but we also need to make sure that the highest value possible is achieved. So we have to figure out a combination of these three items to fill the knapsack. We can solve this problem using brute force, but in terms of computing it is not the most efficient solution. So we have to follow some rules to solve this problem. The first rule is that we can only add an item once, we cannot repeat items. The second rule is we are allowed to not use an item at all. And the third rule is we can break up an item and use a part or a fraction of it. This is where it gets its name, the fractional knapsack. So what's the greedy solution to this problem? These are the steps we will take to solve the problem. Firstly, we will calculate the weight value ratio of each item. Then we sort them according to the ratio, and we add them to the knapsack based on the sorted ratio. And lastly, we divide the last item and we use it to fill the knapsack according to the weight that is remaining. So the ratio is just the value divided by the weight. For the first item it's 6, for the second is 5, and the last one it's 4. So let's sort the items in descending order to the knapsack and let's add them in the knapsack. So we add our first item, we choose item 1 as it has the highest ratio. With a value of 10, after adding it, the capacity left in the knapsack is 60. And then we add item 2 because it's the next highest ratio. After adding it, the capacity left is 20 and the current value of the knapsack is 160. So then let's add our final item to the knapsack. Now for this we have to divide item 3 and 2/3 of it. We choose 2/3 as then the weight will be 20, and as the remaining capacity of the knapsack is already 20, it will completely fill the knapsack and thus give us the solution to our problem. The final value of the knapsack is 240. And here is a sample algorithm for the fractional knapsack implementation.